This is Hyperwall. My name is Steve Platnick. I'm an atmospheric scientist at NASA. And what I want to talk about today is two types of products we do. One is nitrogen dioxide, NO2, and the other is Earth at night, lights at night. And you ought to be asking yourselves, what could those two things possibly have to do with each other? So let me give you a little background. Occasionally, I'm given presentations. They cover a lot of the work that NASA does. And what I love to do is look for threads in there that are linked. So I'm going to try to link together a story. And we're going to start off with air quality, at least as represented by NO2. So I think most of you know that NO2 is a product of fossil fuel combustion. The big, heavy contributors to that are vehicular traffic, internal combustion engines, but of course coal-fired power plants as well. So this is from the OMI instrument on Aura. Now OMI, another to digress a little bit, much of what we do at NASA is international and domestic partnerships. So OMI is a Finnish instrument that was procured by the Dutch that went on a US spacecraft called Aura. So that's the kind of collaborations it takes to get the data that we work with. So with OMI, it gets column NO2 measurements. That's using data in the sort of the deep blue 400 to 450 nanometer region spectrally. You pull out NO2. And so this is a global map representing the average for 2014. So you see the bright spots. By the way, this is in petamolecules per square centimeter. It's not something I work with easily. But a lot of work has been done with ground-based air quality measurements to show that there's a very high correlation between the column NO2 and what's actually measured in the ground, on the ground. So to that extent, if you're looking for trends, if you're looking for relationships, a column amount tells you a lot. But at any rate, you see a lot of the sort of locations that tend to pop up. You've got the eastern seaboard of the US, the mid-Atlantic, and the Northeast with his combustion. Vehicular traffic is a lot of that, but also coal-fired power plants in the Ohio Valley, and we'll get to that in a second. You also see Europe, and of course, China lights up really high. Occasionally, you see other spots throughout the world as well. But I don't want to go into those details. Let me now go to a trend that we have for the central and mid-US. And this is a success story. What this is showing are the changes in NO2 column over a period from 2005 to 2011. So it's not an animation. You're looking at the yearly 2005 column, and you're fading the image into the 2011. And you can see remarkable reductions in here. And along the Ohio River Valley, where a lot of the coal-fired power plants are, what you're seeing is the impact of regulations by our country, by the Environmental Protection Agency, providing cleaner air quality for all. And the one thing I forgot to say is that NO2, in addition to causing respiratory problems, it's also a gas that leads to both ground-level ozone production as well as aerosol and particulates. So a lot of health consequences. The reason you see most of these decreases, the regulations, is now those coal-fired power plants are putting ammonia into the stack that I'm told by the chemists creates a really remarkable change from NOx to molecular nitrogen and water. So very benign stuff. So you see the impact of this. So very good news there. Let's go to some place where maybe not so good news. But again, it shows the impact of population, the impact of economics, energy production, and the changes of all those. So this is the Middle East. This is from 2005, but now it goes beyond 2011. It goes to 2014. And these are the trends or the changes. I don't know if you can see there. The reds are an increase and the blues are a decrease. And let me see where I'm located here. Here I am. This is where I want to go to. So you have Aleppo over here. You have Damascus here, and you see large reductions in NO2, no doubt related to the war and to the energy production going on there. If you see this little red dot or this orange right there, this increase, this is a refugee camp called Zatari. And At the time of 2014, when this ends, there were about 80,000 refugees in this camp where there was nothing there before. And that's gone down a little bit. But about a third of the Syrian refugees have gone into Jordan. And so that's what you're seeing here. So these trends here represent something completely different than what we were seeing before. And it involves human population movement, as well as a very sad story about a civil war. Let's go to the next one. And this is the last one I wanted to show you about NO2, and this is pretty remarkable. This is looking at shipping lanes, and you can actually pick up NO2 signatures if you average long enough. Now, this is a multi-year average, I believe. I don't have it on here. But can you see these sort of bright spots in the shipping lanes? Singapore is sitting right here. You've got lines going from Singapore to China, Sri Lanka, Red Sea, Gulf of Aden. It turns out that Singapore is the second largest port in the world. It's only second behind Shanghai. So in this case, there's something like 30 million containers shipping out of there per year. And if you want to compare that to the US, if Wikipedia is true, it turns out that Long Beach is about 8 million of these standard 20-foot shipping containers per year. So you have a factor of 4 or 5 more shipping coming out of Singapore. And it's remarkable that you can actually see that economic and transportation activity showing up on these images. So remember I told you I was going to get to night lights, and you might be confused about how that transitions from NO2. So let me just take a detour and talk a little bit about a satellite we have that has precipitation radar on board. And again, this is another partnership, this time with the Japanese, JAXA. And what you're seeing here is on September 18th, when Hurricane Maria from this past year was a Category 4, the GPM spacecraft flew over. In addition to the microwave radiometer, which showed something like 6 to 7 inches of rain per hour in some of these bands, here's the precipitation radar. And some of these, as you move through again, you'll see some of these very concentrated convective regions in that. We're reaching up to about 16 kilometers. And one of the issues with hurricane intensification, it's thought that when you have a lot of these hot towers, these large convective regions near the eye wall, it's an indication of intensification. And within about a half a day, it went from Category 4 to Category 5. When it went over Puerto Rico on the 20th, it was back to a Category 4, but of course it was devastating. So now let's go back to Earth nights that I'd mentioned before. Well, let's see what this means. And what we're going to do is we're going to look at the impact that Hurricane Maria had on the infrastructure, the energy production infrastructure of Puerto Rico, but we're going to use night lights to do that instead of the NO2 product. Oops, well, let's go back to the previous one. So I wanted to give you an introduction to the night lights. So we've had satellites for the last 30, 40 years that provided enough sensitivity that they could detect city lights and natural lights during the nighttime. With the advent of the SUMI NPP spacecraft and the day-night band-on-veers, we now have like a factor of 4 improvement in spatial resolution and maybe a couple of hundred times improvement in sensitivity. So we're able to do a much better job in looking at the night lights. And by the way, this is like 750 meter resolution we're looking at here. So this is a composite for 2016, and what's been taken out of here, or what's been removed, is natural light, so reflection from moonlight, for example, and so on. And this then represents the human activity that contributes to lights. And if you look carefully, you can find a lot of, fishing vessels, gas flaring, and of course most of this is electrical light activity. But even in this, because we've been talking a little bit about the economic aspect of what you're seeing, you can see the differences in economic and political activity if you look carefully at this particular map. So what's really interesting then is to take data like this and start looking at trends. And what we're doing at NASA is trying to get this data into a near real-time capability so it can actually be used for decision makers. And to give you an example of how that might be useful, now let's go to the next slide to look at San Juan, Puerto Rico. And what you're going to see is those Veers day-night band city lights from before and after the overpass of Maria. So here you are. If you're familiar with this the city, maybe you would recognize some of the highways, and you can see the type of resolution you're able to see there, the city lights. Now we're going to move through a week. I believe, yeah, this is about a week after Maria went over the island on September 20th. And at that time, from the island completely, it was something like maybe only 20% of the electrical generation capability was there. 2 months later, when I originally gave this talk to some visitors, only 50% of the energy production was back. Last week, according to a New York Times article, it's something like 70% now, so still a long way to go. And now let me feed back to the NO2 in particular. This is Aleppo, and what you see here is a graph of the integrated nightlight energy, and it's plotted up through a recent time period. And just devastating to look at the type of impact of the war on that particular city. We also have imagery, which I'm not going to have time to show, that looks at some of the increase in those nightlights in the refugee camps as they come online. In addition to Zatari, which I showed you in the NO2 image, there was an Emirati-funded refugee camp just to the west of that. And again, with this kind of data, you can see the new activity with the lights coming into that area that previously was unoccupied. And I've got, just to wrap up, we were talking about air quality, we were talking a little bit about choices in terms of regulation, environmental regulation, the impact of population movement. Oops, I had one more, okay. So this is, again, city lights. This is kind of a neat, because a lot of the images I'm showing you do not comment well on human and their behavior in their institutions. I want to show you something a little more fun. We're trying to do science with these night lights. So in this case, this is the seasonal change in the Washington, D.C. area. And maybe you can recognize Washington, Baltimore, Annapolis is out there. You may be able to see some things. So what's happening here is if you see green, there's a big seasonal change over the course of a year in the brightness in that particular area. And so what you're seeing is in places that have very little vegetation or relatively little vegetation, a lot of exposed infrastructure and concrete, including Dulles International Airport, right? There's a very low seasonal change because there's nothing there to get in the way of the lights. It's not that the activity here is any different usually in the seasons. So what you're seeing here is a metric for the vegetation that's in that area. So really amazing kind of unique things you can do with this data. And it's because the quality of this is so much better than what we've had in the past. I think we're still learning how to do that. So with that, I'll go to my final slide. Please skip one, go to the final one. And I just want to say that what I have not talked about yet is what we're doing with both air quality and the use of this data. It's more than just observations. It's also about integrating those observations into models. And I could only pick one example to show you, and I wanted to pick something that had to do with air quality. There's certainly plenty. But this is the Goddard GEOS 5 model in the Goddard Modeling Assimilation Office. And this is showing 4 different types of aerosols that was run from the period from 2005 to 2007. And I just leave it to you to look at this. You can be mesmerized by it. But in particular, the green there is biomass burning from fires. In Africa here, probably about 70% of the total biomass burning is going on there. And it's all human caused. It's been going on for millennia. It's for agricultural purposes. But you can see that what one country does and puts into the air ultimately finds its way somewhere else in the world. So let me just stop there so we can continue on. If you have any quick questions I can answer, or we'll go on to the next speaker. Thank you.